What is cylinder head porting? Cylinder head porting is the process of modifying the intake and exhaust ports within an internal combustion engine's cylinder head to optimize airflow. Factory manufactured cylinder heads are often designed with compromises for cost, durability, and mass production, resulting in suboptimal shapes, rough surfaces, and misaligned features that restrict air and fuel mixture entry into the combustion chamber and exhaust gas expulsion. By reshaping and smoothing these ports, porting improves volumetric efficiency, the engine's ability to fill the cylinders with air/fuel and clear exhaust, which directly boosts horsepower, torque, fuel efficiency, and overall performance. This is particularly valuable for racing, high-performance builds, or restoring older engines, where even mild porting can yield 10 to 20% power gains without major internal changes. Why are carbide burr tools essential in this process? Carbide burr tools, also called carbide rotary burrs or die grinder bits, are specialized cutting tools made from tungsten carbide, a material known for its extreme hardness, up to HRC91, heat resistance, and abrasion tolerance. They are attached to high-speed rotary tools like die grinders, pneumatic engravers, or flexible shafts and used to remove material from the cylinder head's ports and chambers. In cylinder head porting, these tools are indispensable for several key reasons, as they enable precise, efficient, and effective modifications that other tools simply can't match. Below, I'll break down their importance step by step. Superior material removal and durability. Cylinder heads are typically made from cast iron or aluminum alloys, which are tough and prone to heat buildup during machining. Carbide burrs excel at quickly and aggressively removing excess material, such as casting flash, rough edges, and obstructions in the ports, without dulling rapidly. Unlike softer steel or high-speed steel (HSS) bits, carbide resists wear even under prolonged use, lasting 10 to 20 times longer in demanding applications. This durability reduces tool changes and downtime, making porting faster and more cost-effective. For example, in initial rough shaping, larger carbide burrs, e.g., cylindrical or tree-shaped, can shave away up to 3 to 4 inches of material depth in ports, which would take hours with manual files or abrasives alone. Their double-cut or single-cut flute designs, cross-cut patterns, create finer chips that evacuate easily, preventing clogging, especially critical when working aluminum heads, where special non-ferrous or aluma-cut burrs are used to avoid buildup. Precision and control for optimal airflow shaping. Porting isn't just about enlarging passages, it's about creating smooth, aerodynamic contours that minimize turbulence and maximize velocity. Sharp factory edges, misaligned valve seats, and uneven bowl areas can cause air to stall or create eddies, reducing flow efficiency. Carbide burrs provide unmatched precision for blending these features, chamfering corners, and creating radius blends, e.g., in short side turns or combustion chambers, that promote laminar flow. Available in various shapes, like ball nose for concave cuts, cone for countersinking, flame/egg for tight radii, and tree for long, narrow ports, they allow porting experts to access hard-to-reach areas, such as deep intake runners or exhaust ports up to 4 to 6 inches long. This level of control ensures modifications enhance scavenging, exhaust clearing, and filling, intake charging, without compromising structural integrity, potentially increasing airflow by 20 to 50% as measured by flow benches. Poor tools could lead to uneven surfaces that actually worsen performance, but carbide burrs enable repeatable, high-accuracy work suitable for both DIY enthusiasts and professionals. Efficiency and time savings in the porting workflow. A typical porting job involves stages: inspection/marking, rough removal, blending/smoothing, and finishing, often with abrasive rolls or flap wheels. Carbide burrs handle the heavy lifting in the rough and blending phases, removing material 5 to 10 times faster than sanding cones or files while leaving a surface ready for final polishing. This speeds up the process. What might take 18+ hours manually can be reduced to under 3 hours with carbide tools and a die grinder. They're versatile across materials, cast iron, aluminum, even composites, and compatible with common setups like air-powered die grinders, 90 to 120 psi, or electric rotary tools. Kits often include extensions for extended reach, and their use with lubricants, e.g., WD-40 for aluminum, prevents overheating and ensures clean cuts. In professional shops or DIY garages, this efficiency translates to lower labor costs and quicker engine rebuilds, making high-performance modifications accessible. Safety and finish quality. While porting generates hazardous dust and debris, requiring respirators, eye protection, and vacuums, carbide burrs produce finer, less aggressive chips than coarser abrasives, reducing the risk of embedded particles or tool breakage. Their reduced bounce compared to HSS tools provides better control, minimizing the chance of gouging delicate valve seats or chambers, which could cause engine failure. The resulting surface finish is smoother, promoting better combustion turbulence and reducing thermal distortion, uneven heating that warps cylinders and shortens life. This not only improves power but also enhances engine longevity by minimizing stress on pistons, rings, and seals. Potential drawbacks and best practices. Carbide burrs can be aggressive for beginners, potentially removing too much material if not used carefully. Always start with coarser grits for shaping and progress to finer ones. They're more expensive up front, $20 to $50 per burr, but pay off in longevity. For aluminum, opt for double-cut or aluminum-specific burrs to avoid galling, and pair with variable speed grinders, under 18,000 RPM, to prevent melting. In summary, without carbide burrs, porting would be labor-intensive, imprecise, and less effective, limiting engine potential. They are the stock and trade of head porters, transforming suboptimal factory heads into high-flow powerhouses. For hands-on examples, resources like David Vizard's porting guides or kits from brands like Trick-Flow and Eastwood emphasize carbide burrs as core components. If you're porting yourself, invest in a quality set and practice on scrap material first.